Hello students, welcome to Anne's classes. Let's do special types of quadrilaterals, chapter 17. Exercise 17 is on page number 203 and we have the first question, which is the multiple choice type. I hope children you have gone through the concepts of quadrilaterals, which is there in the beginning of this exercise. I hope you've gone through everything and have understood the various theorems. So let's begin this. In question 1, in the given figure, ABCD is a parallelogram. So this is the figure given to us, A, B, C, D. This is a parallelogram. Now look at the rest of the question. Angles DAB. Now DAB. So that is here. So let's mark that. So this is a DAB. This is angle DAB and angle ABC. So let's mark that also. So this is angle ABC. So here what are they telling us? They are saying that these two angles are in the ratio 5:7. These two angles are in the ratio of 5:7. Now we have to find the value of x. Can you see this side CB has been produced and we have an angle here. We have to find the value of this angle. So once we find the value of these angles, we'll be able to find the value of x. So here let's begin by saying let angle DAB be 5A. Why 5? Because the ratio says 5 here. Okay, so this is the first angle. So the first number is for the first angle. Second number is for the second angle. So let angle DAB be 5A. Let angle ABC be 7A. I have used the letter A here instead of the letter X because we already have an angle X here. So these are the two angles given to us. Now here we also know one property of parallelograms, that is adjacent angles are supplementary. Adjacent means next to each other. So these are two adjacent angles and they are supplementary. That means they add up to 180. So that means angle DAB, if I add angle ABC to it, we get 180 degrees. And we said let angle DAB be 5A and let angle ABC be 7A. So together this will add up to 180 degrees. 5A plus 7A is 12A. 12A is 180 degrees. So now we can find the value of A. A will be 180 divided by 12. Now, if we have to cancel this, we say 12 ones are 12 and 12 into 15 is 180. That means we have found the value of A. A is 15 degrees. So now that we have found the value of A, we can easily find the value of X. You know how? Because we know this ABC is 7A and angle B, this point is angle B and angle X are a linear pair. They are a linear pair of angles. Now we can also take it another way. Now, first of all, linear pair of angles equals 180. So we can find out the value of x. Now, if we have to extend these, these become parallel lines and this becomes a transversal. So when this becomes a transversal, again, I can take these two as alternate angles and alternate angles are equal. So you can use any property to find the value of x here. So first we can say angle B, okay, angle B or angle ABC. Angle ABC, we said is 7A, which is equal to 7 into A and A is 15 degrees. And 7 into 15 is 105 degrees. Now to find the value of angle X. So that will be angle ABC plus angle X is equal to 180 degrees. Okay, one reason is because they are a linear pair of angles. Now, if you're going to take this angle and this angle, you can just say they are alternate angles and they are equal. So I will continue this here. So now angle ABC. How much is angle ABC? 105. So let's write that. So 105 degrees plus x is equal to 180 degrees. So now to find the value of angle x or simply x. Okay, we just have to write x. The value of angle x will be 180 degrees minus 105 degrees and therefore x is equal to 75 degrees. So we have found the value of x and x is 75 degrees and that will be option C. So choose option C because option C is 75 degrees. So this is our answer. Question 2. ABCD is a rectangle. Okay, so let's have a rectangle there. Now this is ABCD. This is a rectangle. To make it a square, if I have to change this rectangle to a square, which of the following conditions must be satisfied? So right now we have a rectangle and you can see the diagonals here. Now if I have to change this rectangle to a square, which of these conditions must be satisfied? Should AC be equal to BD? Now this is AC and BD. Should the diagonals be equal to each other? Or AC and BD. Should AC and BD be perpendicular to each other? Perpendicular lines are lines that touch another line at right angles. Or should the diagonals bisect each other? Or should AB be equal to CD? Okay, so this is the rectangle. So what is a rectangle? The opposite sides are equal. They have diagonals which are also equal. But look carefully, the diagonals are not meeting at right angles. So if a rectangle has to be changed into a square, you will get a figure like this, where the diagonals bisect each other at right angles. The square has been made from the rectangle has now changed. Now can you see the diagonals? The diagonals will bisect each other at right angles. That means here I have a right angle. Okay, here I have a right angle. The diagonals are bisecting each other at right angles. So that means they are perpendicular to each other. AC is perpendicular to BD, that is option B. So that is our answer. Option B, AC is perpendicular to BD. Perpendicular lines are lines that meet another line at 90 degrees. Question 3. In a quadrilateral ABCD, so let's have a quadrilateral. AB is parallel to DC. So where is AB? This is AB. This is parallel. So these two are the parallel lines. Now, which of these conditions will be satisfied here? Okay. So here, if these two are taken as parallel lines, now if I extend the parallel lines and I consider AD as the transversal, if I consider AD as a transversal, then let's look at this. Angle A plus angle B. Where is angle A? Angle A is here and angle B is here. So these are two parallel lines and this is a transversal cutting it. Now the question is R angle A plus B equal to 180? No. Okay, this is on a different line. So we are talking only about angles here. We are only talking about these angles. Okay, so let me mention that here. So we have angles around this and we have angles around this. So this is all that we are talking about. We are not talking about angles B and C. You cannot include B and C here because these are the two parallel lines and this is the transversal cutting it. So let's look at point option B. Angle A and angle C are 180? No, we can't even consider. Angle C and angle D are 180? No, again C is on a different line. Angle A and angle D are 180 degrees. Angle A and angle D, that is these two angles, angle A and angle D, when you add it up, does it give you 180? Yes. If these two are parallel lines and this is a transversal cutting it, D and A will become interior angles or co-interior angles or allied angles. And we know that co-interior angles are supplementary or allied angles are supplementary. So which is our answer here? Our answer is option D. Angle A plus angle D is equal to 180 and the reason is co-interior angles are supplementary when two parallel lines are cut by a transversal. So here we have a reason when two parallel lines are cut by a transversal, the co-interior angles are supplementary. So angle A and angle D, okay, angle A and angle D are co-interior angles. They are both co-interior angles. So they will be supplementary. You can also call them interior allied angles. So co-interior angles or interior allied angles, they are supplementary. So they will add up to 180 degrees. Question 4. The diagonals of a quadrilateral are equal and bisect each other. Then the quadrilateral is which of these figures? Okay, now they are equal and they bisect each other. So let's draw the first one, now the square. This is what a square looks like, and these are the two diagonals, and as you can see, the diagonals are bisecting each other, but they're bisecting each other at 90 degrees and they are equal. So here we can follow this. The diagonals of this quadrilateral, that is a square, are equal and they bisect each other. Only additional thing is they bisect each other at 90 degrees. Now let's take the next one, rhombus. Rhombus looks like this. It's like a tilted square. Okay, and the diagonals of the rhombus are not necessarily equal, but they bisect each other. Then we have the next one, parallelogram. So this is what a parallelogram looks like, and we have diagonals which are bisecting each other, and that doesn't have to be equal. The diagonals don't have to be equal unless the parallelogram is a rectangle. Now the rectangle, okay, the rectangle is a quadrilateral whose diagonals are equal and they bisect each other. So we have the four figures here to help our understanding better. So the answer to this question is answer D, rectangle. Question 5. A quadrilateral will be a square if its each angle is 90 degrees. Yes, it has to be 90 degrees, but we need to have one more condition. So here it says each angle is 90 degrees and the diagonals are equal. Okay, but more than the diagonals, we have to think of something else. Now the third one is all the sides are equal. That's also true. But look at the fourth one. All the sides are equal and each angle is 90 degrees. So both these conditions have to be there if that quadrilateral is going to be a square. So our answer is option D. All the sides are equal and each angle is 90 degrees. Question 2. In parallelogram ABCD, angle A is 3 times angle B. Okay, and find all the angles of the parallelogram. In the same parallelogram, if AB is equal to 5x minus 7 and CD is equal to 3x plus 1, find the length of CD. So first is we have to find all the angles of the parallelogram. That's the first thing. So what is given to us? We are given that ABCD is a parallelogram. So that is given to us. ABCD is a parallelogram. Okay, so first thing we write that parallelogram. Then what else is given to us? We are given that angle A is 3 times angle B. So let angle B be equal to Y. Then angle A is 3 times of angle B. That means it will be 3Y. Okay, so all this is given to us. ABCD is a parallelogram. We have it here. Angle B is equal to Y and angle A is 3 times of Y because it's 3 times of angle B. Now we are going to find out all the angles. So first thing we have to remember is that AD, let's take AD to be parallel to BC. Now where is AD? This is AD and this is BC. So we are going to take those two as two separate parallel lines and we're going to consider it to be extended. So if we have one there and one here, so we have AD and BC which are parallel to each other. So we're going to take this as a parallel line and we're going to take one of these lines. Now here we need to find the angles, isn't it? So we're going to take this line AB as a transversal. So when we extend it, it's like this. So we have two parallel lines cut by a transversal. So now we're going to use the properties of parallel lines cut by a transversal, and according to that, angle A, that is this angle, plus angle B, okay, will be co-interior angles, and we know that co-interior angles are supplementary. That means if I say angle A plus angle B, what should I get? I should get 180 degrees because they are co-interior angles or allied angles. Allied angles will always be supplementary. And we know here, we have written here angle A is 3y and angle B is y. So let's write that 3y plus y is equal to 180 degrees. Now let's simplify this. 3y plus y is 4y. 4y is 180. So now we can find the value of only y. Y is equal to 180 degrees divided by 4. And that will be 45. So if angle y is 45, then that is actually angle B, isn't it? So that means angle B is y, which is 45 degrees, Angle A we said is 3y, that means 3 into 45 degrees, which is 135 degrees. So we have found two angles. So let's write it there. So B is 45 degrees, A is 135 degrees. Now look at angle A and angle C. They are angles of a parallelogram. And what do we know about angles of a parallelogram? Angles of a parallelogram, the opposite angles are equal. So if this is 135, C will also be 135. So we can write that angle C is equal to angle A. And what is the reason? Opposite angles of a parallelogram are equal. Parallelogram are equal. Okay. So that means angle C is 135 degrees. So let's write that here. Angle C is 135 degrees. Now we can find angle D also, because here again we can use the property opposite angles of a parallelogram are equal, and D is opposite B. So this is also 45 degrees. So let's write that angle D is 45 degrees. So now we have all four angles. Angle A is 135 degrees, B is 45, C is 135, and D is 45 degrees. So we have found the first part of the question, the answer to that. Now we have to go on to the second part of the question. The second part of the question is, if AB is equal to 5 minus 7 and CD is equal to 3x plus 1, find the length of CD. So here AB is 5x, so this is AB, 5x minus 7, and CD is 3x plus 1. So this is given to us. Now we know about the sides of a parallelogram, isn't it? That is, opposite sides of a parallelogram are equal. That means AB is equal to CD. So we can write that. So let's write that AB is equal to CD. Now substitute. AB is 5x minus 7, and that is equal to 3x plus 1. Now we can find the value of x first. So let's bring all the x to one side. So 5x minus 3x, and we'll take all the numbers to the other side. I have 1 and minus 7 goes, it becomes plus 7. So here what do we have? We have 2x is equal to 8. Now we can find the value of x. X is equal to 8 divided by 2. And this we know 8 divided by 2 is equal to 4. So we have found the value of x. X is 4. Now we can find the value of CD, because CD is given as 3x plus 1. And now we know the value of x, so that will be 3 into x, which is 3 into 4 plus 1. So 3 fours are 12. 12 plus 1 is 13. So we have found the length of CD. CD is 13. So we can write this as our final answer. Now, no measurement is given for the sides, isn't it? No measurement like centimeters or meters, nothing is given. So you can write this simply as 13, or you can write 13 units. Question 3. In parallelogram PQRS, so we have a parallelogram here, PQRS, angle Q is equal to 4x minus 5 degrees. So let's write that. So this is angle Q. So this angle Q is 4x minus 5 degrees. 4x minus 5 degrees. This whole thing is that. And angle S is 3x plus 10 degrees. So here we have angle S. So let's write it there. So this is 3x plus 10 degrees. This is the value of this angle. Now we have to calculate angle Q. We have to find out the value of angle Q. Now here we have to find out the value of x first, and then find out the value of angle Q and the value of angle R. So now these are the two angles given to us, and we know in a parallelogram opposite angles are equal. That means these two are equal to each other. So we can write that is 4x minus 5 is equal to 3x plus 10. They're equal to each other according to this property of parallelograms. So now let's open this. So this is 4x minus 5 is equal to 3x plus 10. Now we can solve for x here. So 4x is on the side, bring the other x here, it becomes minus 3x. On the other side we have 10, take this minus 5 to the other side, it becomes plus 5. So 4x minus 3x is 1x or x. 10 plus 5 is 15. So we have found the value of x. Now we can substitute it here for q and find the value of angle q. So q is given as 4x minus 5 degrees, isn't it? So in the place of x, we're going to write 4. We're going to write 15. That is 4 into 15 minus 5 degrees. So 15 fours are 60. 60 minus 5 is 55. So Q is 55 degrees. So we have found the value of Q, angle Q, and that is 55 degrees. Now we have to find the value of angle R. Now angle Q and angle R are here. Now can you see PQ and SR are two parallel lines. They are parallel lines and we can take this line RQ as a transversal which is cutting two parallel lines. So in that case angle Q and angle R, both these angles will become co-interior angles. And we know co-interior angles are supplementary. So here first let's write that. So let's write PQ is parallel to SR and angles Q and R, angle Q plus angle R will be equal to 180 degrees because co-interior angles are supplementary. So how much is angle Q? We found out angle Q here, that is 55 degrees. So we can substitute and write angle Q is 55 degrees plus angle R. And what is angle R? That is the angle that we are going to find out. That is equal to 180 degrees. Now we can find angle R, that is 180 degrees minus 55 degrees. Let's subtract and see. That will be equal to 125. So we have found the value of angle R also. So angle R is 125 degrees. So here we found the value of angle Q, which is 55, and now angle R, which is 125 degrees. Question 4. In a rhombus ABCD, if angle A is 74, find angle B and angle C. So that means angle A is 74. This is given to us already. Angle A is 74 degrees. Now we have to find angle B and angle C. Now, in a rhombus, opposite angles are equal. That means if this is 74 degrees, angle C will also be 74 degrees because there is the property of rhombus which says opposite angles are equal. So let's write that. So angle A is equal to angle C and that is equal to 74 degrees. And what is the reason? Opposite angles of a rhombus are equal. Now the next thing is we have to find angle B. We just now found angle C. Now we have to find angle B and that is this angle. And now we know that the sides AD and BC are parallel to each other. You can take these two sides as parallel to each other. In that case, AB will be the transversal. So if you extend this, AB will be the transversal. And we know the properties of parallel lines and transversals. In that case, angle A and angle B will be equal to 180 degrees. So let's write that AD is parallel to BC. So in that case, angle A plus angle B will be equal to 180 degrees. And we know angle A is 74 degrees. It's given to us. So this is 74 degrees. Angle B is what we're going to find out. Together they must add up to 180 degrees. Now we can find the value of angle B. Angle B is equal to 180 degrees minus 74 degrees, which is angle B is equal to 106 degrees. When you subtract 180 minus 74, you will get 106. So we have found angle B also. So we have found angle C and we have found angle B. This was question 1. Question 2. If AD is equal to 7.5 centimeters, find BC and CD. Now AD is this. AD is 7.5 centimeters. So we have been asked to find BC, that is this one, and CD, that is this one. Now we know that in a rhombus all sides are equal. So All sides of a rhombus are equal. So that means AD is 7.5, isn't it? That is equal to BC. BC is equal to CD, and they're all equal to 7.5 centimeters. So you can write it separately. BC is equal to 7.5 centimeters and CD also is equal to 7.5 centimeters. That's because all sides of a rhombus are equal. Question 5. In square PQRS, so we have a square PQRS. In this, question 1, if PQ is 3x minus 7, PQ, let's write, if PQ is 3x minus 7 and QR is here, is x plus 3. So QR is x plus 3. We have to find PS, that is this side. Now this is a square and we know all sides of a square are equal. So if we find the measurement of one of these sides, this also will be the same measurement. For that, first we have to find the value of x. So this point, all sides of a square are equal. This is very important. That means what is given to us is PQ, isn't it? PQ is equal to QR. We have values for these, so we are going to use these two sides. Now how much is PQ given to us? PQ is 3x minus 7. This is equal to QR, which is x plus 3. Let's bring all the x terms to one side. So here we have 3x. Let's bring this x to the other side, so it becomes minus x. Then here we have 3, and let's take this minus 7 to the other side, it becomes plus 7. Simplify. 3x minus x is 2x. 2x is equal to 10. So now we can find the value of x. X is equal to 10 divided by 2, which is 5. So we've got the value of x now. X is equal to 5. So this is the first part. Now we can substitute it here. 3x, we can put 5 here, or we can say 5 plus 3 here. We'll still get the same. So let's use this. This is simpler, isn't it? So let's find RQ or QR. QR is equal to x plus 3. That is equal to x is 5. 5 plus 3, which is 8. So 8 units, or simply 8. So if one side is 8, if this is 8, all sides will be 8. So we have been asked to find PS. So PS will also be 8 units. So this is our answer. PS is equal to 8. Now here also, if you substitute x with 5, you will find 3 5s are 15. 15 minus 7 is 8. So here also it's 8. Here also it's 8. All four sides it is 8. So that is our first answer. Second question here. If PR is equal to 5x, now here it's given as PR. Now here P and R will be here. That means it's a diagonal, and QS is also given. This is a diagonal. Now we have to find QS. Okay, so we know that in a square, diagonals are all equal. So let's get our diagonals. So we have these two diagonals. The diagonals are equal. Now PR is this diagonal. So let's write it here. So this is 5x. And the other diagonal QS is 9x. So this is 9x minus 8. And we know the diagonals of a square are equal. So we can write that as PR is equal to QS. And how much is PR? PR is 5x. And that is equal to 9x minus 8. So now let's get all the x to one side. So 5x minus 9x. We're bringing 9x this side, so it becomes minus 9x. And on the other side, we have minus 8. Now let's simplify this. 5x minus 9x is minus 4x. Minus 4x is minus 8. We have minus on both sides, so we can cancel it. So now it's just 4x is equal to 8. So that means x will be equal to 8 by 4, which is 2. So we have found the value of x. X is equal to 2. Now we have been asked to find QS, isn't it? And QS, let's write it here. QS is given to us as 9x minus 8. Now we have found the value of x. So let's write 9 into x, that is 9 into 2 minus 8. 9 2s are 18. 18 minus 8 is 10. So we have found QS, and the value of QS is 10. Question 5. ABCD is a rectangle. So we have a rectangle here. If angle BPC, now we have B, we don't have BP, isn't it? So we have to think about that. BPC is 124. Calculate angle BAP. So there is a point P here somewhere. So that means we have to draw our diagonals. So we know the diagonals of a rectangle are equal and bisect each other. Now this is a very important point. The diagonals of a rectangle are equal and they bisect each other. What is the meaning of this? Okay, so let's draw the diagonals here. So we have the diagonals and this point in the middle is P. That's why here we have angle BPC. So BPC is this, and this is 124 degrees. Now here the diagonals of a rectangle are all equal. All these BD and AC are equal. Now when we say bisect each other, what we mean is BP and PD will be equal to each other. Similarly, AP and PC will be equal to each other. So this you have to keep in mind because we'll be making use of that particular property soon. So what does that mean? It means that BP is equal to PC. So these two lines are equal to each other. So here when you have two lines that are equal to each other, the angles opposite those two equal lines will also be equal. That means this angle and this angle will be equal to each other. So let's write that down very clearly. In triangle BPC, we have triangle BPC. In this triangle BP is equal to PC. So if that is equal to each other, then we can say angle PBC is equal to angle PCB. And what is the reason? The reason is angles opposite equal sides are equal. So this becomes an isosceles triangle. These are equal sides and the angles opposite that are equal. So angles opposite equal sides are equal. So now we don't know the value of these two angles. We'll name it as x. They are equal. So this will be x and this also will be x. And we also know the property of sum of angles of a triangle is equal to 180 degrees. So we can write that. That means we can say 124 degrees plus x degrees plus x degrees is equal to 180 degrees. Now how do we know this? Sum of angles of a triangle will be equal to 180 degrees. So let's simplify that. So that will become 124 plus 2x is equal to 180. So now we can find the value of 2x. 2x is equal to 180 minus 124. Now how much is that? 2x is equal to 56. So now we can find the value of x. X is equal to 56 by 2, which is 28 degrees. So that means we have found the value of this angle and this angle. So let's replace it with 28 degrees in the figure itself to make it easier for us to understand. So 28 degrees here and 28 degrees. So now we have to find angle BAP. Now that we know these angles, we can find angle BAP. So angle BAP, that means we are looking at this here. We are looking at this part, and we should get BAP. So just we are looking only at this triangle inside. Now here we have 28 degrees and this whole thing we know is 90 degrees. It's a rectangle, isn't it? So each angle is 90 degrees. So if we minus this and this, we will get the value of angle, this part alone. Okay, so let's do that. That is, if we have to find angle ABP, if we have to find angle ABP, then we have to know that angle ABP plus angle PBC will be equal to 90 degrees. Now angle ABP we don't know. That is what we are going to find out. Angle ABP, that is this angle in green here. This angle in green is what we are going to find out. Now if we add PBC, that is this angle 28 degrees. If we add 28 degrees, PBC is 28, we will get 90 degrees. So now let's find out this angle ABP is equal to 90 minus 28. 90 minus 28 is 62. So this is 62. ABP. So this we got it as 62. Now we have to get this also. That is, we have this angle here. Okay, so we're only looking at this triangle inside here. That is triangle with the vertices. That is A, B here and P. So we found out this part of B is 62. Now here we have to find this. That is angle P or APB. So now let's find that. So angle APB plus, now look at this angle here, 124. That is angle CPB. Okay, so let's write that, plus angle CPB should be equal to 180 degrees because they are angles of a triangle. The sum of angles of a triangle is equal to 180 degrees. Now angle APB is what we need to find out. So that will remain as it is. So angle APB will remain as it is plus angle CPB. CPB is 124. Let's write that 124. That is equal to 180 degrees. Now why? Because they are angles on a straight line or they are a linear pair. P and 124 are a linear pair of angles. So now we can find angle APB. This is equal to 180 minus 124, which is 56 degrees. So we should keep in mind these. So here we have 62, which we have written here near the green angle. Now we have 56, which we are going to write near the blue angle, so 56. So now we have two angles of this triangle. We can find angle A, isn't it? Because when you add up all three, you should get 180 degrees. So this is angle BAP. This is what we are asked to find out. So let's write that. So let me write that. Angle BAP is equal to angle ABP plus angle APB. All this should add up to 180 degrees. So we have three angles here. BAP is what we're going to find out. Adding the other two angles should come to 180. So this is equal to angle BAP plus, how much is ABP? 62 degrees. How much is APB? 56 degrees. They must all add up to 180 degrees. So now we can find angle BAP. Angle BAP plus 62 plus 56, that will be 118 degrees is equal to 180. So now let's find the value of angle BAP. This will be equal to 180 minus 118, which is 62 degrees. So we have found the value of angle BAP, and that is 62 degrees. The second question, we have to find angle ADP. So that is, now we have these diagonals here. Now ADP, now this is the angle that we have to find. Angle ADP is here. Okay. Now here we have already found out some angles. So this one is 28 degrees. Now we are going to make use of this angle 28 degrees. Now how are we going to do this? Now look at this line AD. Now I have colored it in red, and I have again look at this line. Now these are now two parallel lines in a rectangle. You can consider these two as two parallel lines, and this will be the transversal that is cutting through them. So if you have a transversal cutting like this, then angle D and angle 28 will be equal. Why will they be equal? Because they become interior alternate angles. So interior alternate angles are equal. So we can write this as angle ADP, which we have to find out, is equal to angle DBC. That is equal to 28 degrees. So we have found the value of angle ADP, which we have been asked to find out, and that is 28 degrees, and we made use of this property that interior alternate angles are equal. So we will stop with this for now, children. In our next video, we will continue with the remaining questions. Thank you, children.